Throughout our 45 years of building energy storage systems, we've been able to design systems for every environment imaginable. We literally have systems on every continent on the planet. There's lots of places in the world that need power that just don't have it. And when you look at some of the places where the grid is not reliable and antiquated, bringing storage in makes it an islanded, a much more robust solution in those areas, and that's the next step in what's going to happen. Some of the things that we're talking about in those communities are having the power run through the storage device because it works as a conditioner for the power, right? So we can condition the power to make it continuously steady. If there's a brownout, the system doesn't even acknowledge it, right? It's making up for that. It's not just the power quality. We'll bring green energy to that application as well, right? When we're talking in Kenya, they have a crazy solar penetration, right? We're almost 8.5 hours worth of solar light that they can use a day. Adding that to the resiliency of the system.
As long as those systems have a connection to the outside world, a wireless connection or wired, then we can access it from here.
So with our worldwide deployments, we don't just drop them off and leave. We have the ability to maintain them. We have field service that can travel and do on-site maintenance, but we also monitor them from a distance here in our NOC. We can see when anything's happening, whether or not it's performing the way it's supposed to perform, and if it doesn't, we can send a group out into the field to fix it. All over South and Central America, there's huge wind farms everywhere, but the transmission, getting the power in and out is consistently poor, right? Because the infrastructure is not up to date. In order to make renewable energy as useful and usable as possible, you have to have storage. You really do at this point. It's the ability to have reliable power on site and have power on demand. That's really what it comes down to. And I'm not trying to oversimplify it, but if you look at distribution and transmission, they're two very different things, absolutely. But in the end, it's all about trying to get power someplace.
We come up with an on-site acceptance plan developed by the controls group and approved by the director of engineering. The customer usually gets to review it and approve it as well. And it goes through whatever kind of power testing that we determine is necessary to qualify the system, X number of discharges and charges at certain rates.
As long as we know what the customer wants to do beforehand, we can design it to do whatever they want. And as many things as they want it to do. The ability to come to a company that is most likely the oldest energy storage company in the world with just that much experience and know-how is amazing. And I think anyone that's been in business, there's such an advantage to be able to say, we can build whatever you want. There's a huge redundancy aspect to that, right? To energy storage, which I think is really attractive. And when you look at redundancy and resiliency, when we're talking about grid outages, electricity is the most taken for granted entity in the world, right? People don't even as I say that, most people will be like, oh, I never really thought about that, but that's the case, right? No one notices that the lights are on, right? Until they're off. Storage is just at the very beginning of what we're going to see it's capable of doing.